welcome friends once again to the NPTEL MOOC module on handling unit level data using Stata. There we mentioned handling large scale unit level data. So far we have discussed the data varieties, data collections, and also we have equipped you with the latest know-hows of Stata that we have been handling in last 2 weeks particularly. And now today we will start a new chapter called linear regression analysis using Stata. Now in the last lecture, if I just count down few important points that last lecture particularly we emphasized on last 2 lectures on identifying important factors. So that is largely called factor analysis, and we explained you to analyze the important factor with also their validation, their cutoff points with sporicity measures, also through KMO level and its significance that we have discussed. Why am I analyzing this, recapitulating this, because those factor analysis actually guides us correctly to go for a better linear regression using Stata. Because in linear regression analysis also some of the assumptions has to be validated. Some of the assumptions have to be validated, and the assumptions we will analyze one by one. Now, as a backdrop to linear regression analysis, I just wanted to mention that 3 terms are very important. One is linear, then regression, then analysis by any tools. So, why it is linear? Okay, it has to be validated, it has to be understood correctly. Now, just hardly it requires 10-15 minutes to apply the Stata and get the coefficient or the results, but those results are going to be meaningless if you do not understand the crux of linear regression. So, the foundation of all econometric packages, econometric tools or econometric analysis is none other than linear regression model, and because of its important properties. We will be discussing the Gauss Markov properties as well, but I wanted to give you the background information of linear regression in my first 2 lectures. So, let me start by saying that this is the linear regression, probably the most common statistical technique used by the researchers to answer research questions. Okay, and actually it helps in quantifying trends in data such as connection between students grade. If you take example of performance in a class, so we can able to quantify, for example, for students grades and hours spent by student for studying. So, like how students are performing, those who spend more time in study. So, we can quantify their connection through the regression analysis. This also helps in explaining the effect of increasing or decreasing price of a product on its demand. Okay, the impact of price on demand can also be explained. Those who want to have some market based analysis for pricing strategy. Okay. So, another example of regression or the linear regression is to understand the effect of education on an income, and there are so many examples of such varieties where the regression or the simple regression is going to be useful. So, it is the regression is actually a set of technique for estimating a relation between variables where changes in some variable may explain or possibly cause changes in other variables. Basically, we are going to find out the relationship between one set of variable with another set of variable. Now, you might be little confused with correlation, but correlation only establish the relationship. We are not just going to find the relationship, rather we are going to find certain inferences out of it, some logical conclusion out of it. And those are based on some theoretical models. Okay, theoretical models will explain steadily. So, regression analysis assumes a linear relation between the predictor and the outcome variable. So, predictor we wanted to say broadly speaking the independent factor, independent variable with that of the outcome as the dependent variable. We use regression analysis to predict the value of a dependent variable based on the value of at least one independent variable, at least one to be noted. It may be one also, but then that model will be called bivariate kind. We are going to discuss or simple regression model. Now, this also the regression analysis also explains the impact of changes in an independent variable on the dependent variable. So, impact of changes when this is written, then it also extends some other possible answers, but at this moment in this lecture we are not clearly explaining the impact as such, but we are finding out some possible impacts, but impacts cannot be rationally validated through the OLS or the simple regression model. Now, this regression analysis determines the strength of relationship between one dependent variable, as we are already cited the example, between one dependent variable, that is y, we generally denote with y, and a series of independent variables usually denoted with x. Okay. So, this also helps in forecasting values of y variable from the values of x variable. We broadly speaking we can predict, okay, for some future variable. Now, let us come to some basic fundamental aspects through the diagram, that if there exists linear relationship between two variable, independent and dependent predictor or outcome variable. So, on the first left hand side two diagrams speak about linear relationship, because the trend of rise or fall is more or less confined within a linear line. Okay, a linear line can be predicted out of it or estimated out of it, whereas in case of the other two, the right hand side two diagrams, the trend seems non-linear. Okay, that it's neither just straight line, neither straight line upward or downward. Both the aspects are visible. It is upward and the movements are very dynamic. So, it is largely mentioned as curvilinear, okay, curvilinear relationship. So, this is also called nonlinear relationship. This is also called sometimes we say quadratic relationship, if quadratic relationship is there defined and identified by our tools. Now, to simplify further the relationship between two variables, if on the left hand side again, if it is confined within certain limit, okay, upper and lower limit is highlighted by the red lines. So, that we say they have strong relationship, but on the right hand side, if it is the variability is much higher, okay, from the trend line, that is the board line, if the variability is much higher, but still captioned within a limit, but the limit is defining as having weak relationship. Okay. In this case the variability is very less, okay, whereas in this case the variability is much higher from the trend line. Alright. So, those who are new to econometrics model, I am trying to explain for you, because for students economics who or management who have already applied linear regression model may not be it might be repetitive, but we have to do it for our larger audience. Okay. So, I am trying to clarify. Now, coming to the relationship between x and y, when there are no clear trend defined and we are forcefully deriving a trend line, but the trend line, though it shows a trend line, but actually it is not capturing all the variabilities correctly. So, it seems there is no, we can draw the trend line could be like this also, could be like this also, could be like this also. Okay. Any possibility is there in this particular relationship. So, the computer might generate in one instance, it might simply generate a trend line, but that is not the final one. There are multiple trend line possible. So, therefore, it is not defined as having any relationship. Now, whereas in the bottom diagram, it clearly shows that the trend line does not have any variability. It has a trend line, but it is constant, is not it. So, now irrespective to the change in x, y is not going to change. So, when y is not going to change, that means you are not going to find out any implications of x and on y. Whereas, in case of the first diagram, the variability is very sporadic. Okay. So, r value is going to be is going to be very close to 0. Okay. So, second one basically it is a no trend, it is constant, more or less constant. Now, coming to further clarification of the variables, those are dependent and independent, though we all know the meaning of it, but there are some important aspects we need to highlight. So, broadly it is dependent variable or independent variable. Now, dependent variable is the one that is actually affected by another variable or another set of variables. Also, this is the dependent variable is called in econometrics language, we say regressand, response variable, outcome variable, study variable, explained variable, or simply we take y as the notation for it. Whereas, in case of so let me come to this point once again. So, do not be confused that if any time they are using regressand, response, outcome variable in some of the books. So, do not get confused, they simply mean this, alright. Similarly, in this case independent variable variables, these are the ones that believed to be the cause of the result or have an influence on another variable. Okay, that this is actually influence another variable. This is also called in econometrics language regressor. This is called regressand and here it is called regressor. Okay. So, and predictor, okay, experimental variable or explanatory variable. Here we say explained variable, here we are saying explanatory variable, okay, and noted by x. Alright, or x's, number of variables of x is there, then xi till n is generally mentioned. We are going to discuss in our slides. So, the dependent variable must be a continuous variable so far as our regression is concerned. We are going to discuss that if it is not continuous, then there will be some advanced model. Okay, we will continue those discussion in our next week, not in this week. So, our next module are going to discuss or address non-continuous variable as well. So, but at this moment we will be emphasizing continuous variable for a simple regression analysis. The independent variables can take any form, okay, can take any form. Now, so restriction is on dependent variable, I am just clarifying to everyone. Now, restriction is very little, there are some possibilities, very little on independent variable. It could be of any form, maybe continuous, maybe discrete, maybe indicator variable. Okay, indicator simply a dummy variable. Okay, yes or no, it is not a continuous variable nor a discrete variable. Those clarification we have already made in our previous lectures regarding defining variables. So, coming to the explanation with an example, we suppose we are interested in knowing why some students perform better as compared to others. This might be because some students spend a little more time in their study. So, is not it better to investigate the effect of their relative more hours spent on studying as compared to others in terms of their performance, okay, as an outcome variable. So, for that our dependent variable in this particular example is our performance of the student in terms of grade, okay, or the marks obtained, whereas the independent variable for this particular one is hours spent for studying. Okay. So, we are not now mentioning the quality hours we can discuss, but in our example it is only simply hour. Okay. So, so higher the marks obtained by the students can easily be estimated through this approach. Now, this slide is very interesting to note, because we are addressing some clear indication of the right model to be picked up given the data and the nature of data. Now, the nature of dependent variables suggest some type of models applied, and please take a note, this is I am in my knowledge the most important aspect to be guided from our lecture of this today, that if your y, that is the dependent variable or the explained variable, if it is regressant, if it is y and that is continuous, and you should apply linear regression model. Okay, but if it is, as I just said, if it is not continuous, but it is in binary form, okay, binary form, then 1 0 kind are there, then the dependent variable is no more continuous. So, most appropriate model is logit or probit. Okay. Then these are also called these logit and probit models are also called limdep. Why limdep? In short I am using, but there is a package, there is a statistical package called limdep, but I am not going by the package, I am simply trying to say limited dependent variable. Okay. There is the dependent variable is limited by certain particular discrete numbers, and those are in binary forms. Now, if it is in categorical form, also limdep is applied, but that is also limdep is limited dependent variable models are applied if it is categorical, not binary. So, in that case it will be multinomial logit, okay, or multinomial probit. Okay. Now, question is whether logit or probit to be applied, it depends upon the distribution function of the error term you have. If the error term is the distribution is stochastic, okay, stochastic, then probit is the base fit. Okay. Otherwise, if it is non-symmetric, then logit is the base fit. Okay. We will explain in our next week lectures on limited dependent variable models. So, we will clarify further details to it. Now, coming to ordered categorical dependent variable, when it is order, okay, not necessarily it is binary, not necessarily it is categorical, but ordered form. Okay. That means like I have given you the example of standard of education, okay, standard of education case, even in standard of living also, the lower standard of living, then middle, then upper, okay, those are clearly categorical, but ordered. Okay. In that case, so we use com-logit model, or that is sometimes we said ordered logit model. If you search it in Stata or even in Google, ordered logit or probit model. Okay. So, those clarification will be coming to your screen. So, in short it is called com-logit model. All right. Now, there are some other classification other important, I have discussed these in one category. Now, another aspect I am going to emphasize here called if your y is count data, okay, there is no continuity, only counts how many important points of counting is possible, it does not have variability in its own data. Particular pockets of counting is there. If it is count data, then Poisson regression model is applied. Poisson regression is the best fit. Okay. So, Poisson regression is the best fit and you must apply accordingly. But right now we are not explaining everything, we will open the discussion little more later, but not exactly all the instrument we are going to use for because of time paucity, because of confining the analysis within the limit of our module. So, if we have repeated binary dependent variable, your dependent variable you have in particular time period, that is with let it be in binary or even any other form, if that gets repeated in another time period, usually we refer to as panel. Okay. So, panel having a time component, since it is a time component in different time period, there is a possibility of repetition of that numbers of the dependent variable. So, in that case we will be applying panel probit or panel logit depending upon the distribution, okay, of the data. So, these are I think a very good starting point. This slide I suggest everyone please try to remember and try to logically remember and for better application. Now, let us make a move to the some set of other arguments, other understanding of linear regression analysis. like this is most commonly used method to examine the relationship between a quantitative outcome and one or more explanatory variables. We have already discussed couple of minutes back. The linear regression model really describes how the dependent variable is actually related to the independent variable. So, this relationship between the mean of the response variable and the level of explanatory variable assumed to be approximately linear or straight line, that is important. Okay. The mean response is important because where to compare. Okay. The trend value always takes the mean from the mean response variable and the level of this explanatory variable, that really assumes one of the important assumes a linear approximation, that is usually a straight line, we have already discussed. The meaning of linear regression model refers to linearity in the regression coefficient. Now, this is another most important aspect, must be understood, and usually this is asked in most of the interviews to the candidate who appearing for faculty position, appearing for PhD selection. Now, why am I saying linearity in what? Your linearity in the regression coefficient, not with the regression or not with the variables. Variable, now you have to be clarifying very clearly that not necessarily it should be linear, not necessarily it should be, your model should be linear with the variables. Variable might be in square form, may be in non-linear form. Okay, but your coefficient, that is we are going to discuss what is called coefficient, what are the variables in the equation form in our next slide. I am just trying to give you the background that the linearity in the regression coefficient, that is the betas we are emphasizing, and not linearity in the y and x variable. Okay. So, not linear, which I just wanted to say, y and x variable, it may be linear, may be non-linear, it does not matter. Okay. It only matters that the coefficient which you are going to estimate, our estimation should be actually linearly established. Okay. So, if that is in beta square and beta q, it is very difficult to estimate. All right. So, y and x variable can be either y or x variable, as I just said, can be non-linear, as we wanted to emphasize, could be in logarithmic transformation, may be reciprocal, or may be raised to any power to a power. Okay. So, linearity in beta coefficients means that they are not raised to any power. Okay, and or are divided by other coefficients or transfer such as log. Okay. So, basically it should not be in this form. All right. So, not is the word, that means we should not our beta coefficient should be linear enough. Okay. So, regarding the types of linear regression model, we have some clarification here. You might be a little confused with this. I am just dividing into two. One is when our explanatory variable is only one, okay, with the dependent variable. If it is one, that is either called bivariate model or it is called simple regression model. Okay. Bivariate or simple regression model, it is like this to this, okay, x and its relationship with y, whereas when there are more than x, that is a set of x variables are there, that is called multiple regression model or also called multivariate analysis. All right. Now, let us come to the understanding of a model, of a simple linear structure of the model, which says that if we can write it down like y is equal to beta naught plus beta 1 x plus epsilon. Epsilon we refer to the random error term, okay, and beta naught is the intercept, the population intercept, and beta 1 is called the slope, okay, of the variable x, that is the independent variable, okay, and y is actually the dependent variable we start with. Now, sometimes you might be having some question related to beta naught, why we are supposed to write down. We will again clarify from our diagram. Okay, our diagrams are going to establish a better understanding. Just to mention you the role of intercept with an example that like we have a data set of consumption expenditure as a relationship with income. Okay. So, suppose my dependent variable is consumption expenditure on consumption items, as a function of income of the consumer, per capita income of the consumer. So, now my income is in the right hand side and C is a function of y. Suppose y stands for income or money income, C is a function of m. Okay. Now, m, how should I write it down? So, I should write down here as C, when I am writing simply C is a function of m. So, C I will write down like here as maybe beta naught plus beta 1 m mi, okay, I will and then epsilon I. If I just go by I every time, then you have to write down I, that stands for so many individual responses. Okay. Now, what I wanted to refer in case of this function, that I wanted to clarify this beta naught term. Now, m, with the rise of m, higher the income of the consumer, higher the expenditure is expected. Okay, there exists a positive relationship. So, beta 1 is expected to be positive. Okay. The estimated value of beta 1 is going to be positive while understanding consumption expenditure with reference to money income. But now, suppose income of the person is 0. Okay. Suppose by any reason some explained factors, there are some exigencies in the economy or with the person, that the person could not able to earn any money. Okay. So, does that mean if the equation could have been like C is equal to only beta 1 m. Suppose I am writing down this instead of beta naught. What is the danger we are going to find? So, when this is equal to 0, this tends to 0. So, C should actually tends to 0. Okay, C should be 0, but in reality this is not equal to 0. Even if m income, the person does not have income, the person might get loan to get its consumption fulfilled. Okay. So, even if m stands at 0, though the consumer has to consume something for his or her livelihood. Okay. So, therefore, even if this part is 0, so there is a positive consumption. There must be an autonomous consumption. This is all called autonomous, which is not affected by your m. Okay. So, therefore, beta naught has to be mentioned. Beta naught stands for an autonomous spending, okay, by a particular consumer, and epsilon every time stands for some some error, like whatever we expect with a 1 unit change in m may not be exactly predicting to the change in consumption. There are some fluctuations, that fluctuations are actually identified by the epsilon. We are going to explain everything in our diagram. So, error term is called unexplained random error component. This is also called error term or disturbance term, sometimes denoted by u as well. Okay. And it has to follow a distribution. That is one of the important assumption, and every time we are going to recall you or remind you during our the lectures from now onwards for all the models, that how does your error term explain. If the your error is itself distributing correctly, it follows a standard normal distribution with 0 mean and sigma, that is standard deviation. Okay. If that is there, then we are actually referring to the error term is a standard normal distribution. If that is true, that means our whole data is actually standard normal, because if your error is fluctuating correctly with a normality, that means your data is also following a normal distribution. That is one of the important crux point we wanted to highlight. We will discuss everything eventually. Now, coming to the same simplified model beta x plus epsilon. The above equation is also known as population or true model. Beta x can be treated as conditional mean of y. What do you mean by beta x? How we interpret beta x? This is called conditional mean of y, that is expected value of y given x, conditional upon the given values of x. Generally, how we define dy, if I simply take dy by dx, we get a beta value. Okay. That beta value is corresponding to actually a particular unit change in x. Why I am saying unit change in x? Because beta is not just defined in isolation, it is due to y given x. Okay. So, that is has to be understood. This is a conditional mean, not just an individual mean. So, the meaning this is meaning individual yi, what does this mean? Individual yi value is equal to the mean value of the population of which he or she is member plus or minus a random term. Okay. So, error term could be plus or minus, that has to be understood. Now, in our example, y represents marks obtained by the students and x represents the number of hours spent, the example we have already cited. In that case, the above equation states that the marks obtained of an individual student is equal to the mean marks obtained of all the students with the same hours spent on study, or plus and minus by a random component. That may vary from student to student, and that may depend on several factors. Okay, say other factors, not just the hours important, like the IQ level of the person. Along with that, if you are dealing with multiple regression models. Okay. So, just bivariate analysis is not enough. That is the reason why there are lots of criticism to the bivariate models. We have to include other factors as well. The intercept and slope parameters, intercept which I have started emphasizing, and slope parameter, that is beta, intercept is beta 1, intercept is beta naught. Okay. So, slope parameters are are also called regression coefficients or regression parameters. Okay. This is going to be used throughout our lectures now on. The unobservable error component, that is epsilon, accounts for the failure of data to lie on the straight line and represents the difference between the actual and predicted values of y. So, the error term which we wanted to mention, actually if it deviates from a standard line or standard trend line, that is also called the straight line, that is simply calculated between the changes between the population, that is y, the dependent variable minus the estimated value of that yi. Okay. Y hat we wanted to mention, hat stands for estimated value, that is basically beta x. Okay. The bit estimated value we wanted to find out through the beta x. Okay. So, beta naught plus beta 1 x in our model can be calculated. So, there are several reasons for such differences in terms of epsilon, that is the effect of all the variables not included in the model for various reasons, not readily quantified sometimes some variables, and there are some inherent randomness also in the observations, like human behavior, they respond in a wrong manner, which is little different than that of the average numbers. So, however, it is good to assume that the average influence of such variables on the dependent variable is negligible. So, like it is, if that impact is not negligible, then it will create disturbances to the model. So, the average disturbances should be actually negligible, that is the one of the important assumption to be made in all the models. So, that is why it is distributed with 0, that is why I said it is a standard normal distribution with the mean of that error term is 0. So, the structural model says that for each value of x, the population mean of y, that is over all the subjects who have that particular value of, that is x for their explanatory variable, can be calculated using the simple linear expression with the help of this, okay, beta naught plus beta 1 x. Now, from this diagram we will explain that what is all those terms, what when I say, I have already given you an example of intercept, it must have some intercept between the relations of x and y is our dependent variable. So, it has to be starting with an intercept, because even if x is 0, there must be some positive portion, that is also called intercept term, that is also called autonomous variable, because it is not affected by the change in x. Okay. So, once the x gets changed, it always follow certain standard parameter, okay, with a certain particular rate, it follows with an average change. Okay. So, that parameter is actually beta 1, which explained by a slope, that slope can be also explained with this. Okay. So, this is equivalent to this, any line perpendicular parallel to the x axis, this degree, that slope can be explained with tan theta. Okay. So, can be explained perpendicular by base, that is simply this is here tan theta, this divided by base b. So, basically this is delta y by delta x. Okay. Perpendicular by base defines the slope. Okay. We need to define in a 90-degree line. All right. So, now, so what is our delta beta 1 then? Beta 1 is nothing but the slope, okay, slope of that particular line. So, slope is indicating the angle of that particular angle through tan theta we can define, and slope is derived through delta y by delta x. Okay. Now, question arises, this line is not always a straight line. There are many important frequencies, maybe like this, like there are many responses. This only gives a average trend line. Okay. So, average trend line, but assumption is that if there are these points ups and down, the vertical difference between these two and in all other points any other vertical difference, that those are called error terms, okay, called epsilon. So, epsilon I, why am I writing I? Because there are number of epsilon, not just one epsilon to a corresponding x. So, all those epsilon has to be average with 0, and the average impact of this epsilon has to be minimum most possible. Okay. If that is there, that means if the average is 0, that means we are actually following a perfect trend line and there is a relationship between x and y. Okay. And then only you can postulate number of interpretation of x and y, because we have a clear average value and our regression equation actually explains these things very correctly. Okay. So, I will be explaining another couple of things right now, maybe for till this I will be explaining, then we will move into a next class. So, at this moment I have explained, so most of the concept I have already delivered and discussed with you. So, about beta 1 coefficient slope coefficient I said that it is most important quantities in any linear regression analysis, a value close to 0. What does it mean that? That means it shows little to no relationship, okay, there is no relationship. Now, how does it happen? When there are many error terms, okay, the trend line is very zigzag. Okay, the error term is not having any average 0 error value. So, that means it will be close to 0, that means it might have no trend line, no clear angle, no slope is defined. A large value shows a larger association, okay, between y and x. Okay. So, negative and positive sign shows negative and positive relationship accordingly. So, interpretation of this coefficient is that with one unit change every time, as I said, with one unit change every time one fraction unit, there are many changes like this, like this, like this. Every one unit change, what is the impact on what is the impact on the y term. Okay. So, every one unit change, what is the impact on the dependent variable can be explained. Okay. And that is explained by beta 1, because that is the slope we have already clarified. Now, coming to the population, so far we are actually explaining the population parameters. Okay. We have to explain the sample statistics. In case of parameter we refer to population, statistics we refer to sample. Okay. Now, in that case we are supposed to deal with the estimated value, all right, because it is not possible to go by all population for the regression model, we have to take some sample. So, like here in the left hand panel there are sample the population is given which is randomly distributed and we do not know the relationship, we have to test by some sample. Suppose the sample is taken here, this is the sample is picked up, a random sample is taken, we have to take so many samples from the population, so that our estimation if does not vary much, that means our estimation is actually good. So, that sample now out of the population, now we are deliberately mentioning a hat term, because we are going to estimate the sample, okay, error estimation as well. All right. Now, population linear regression model, which is we have already explained, but now what I am trying to find out is that intercept I have already said. Now, from the linear line in the as highlighted in the red line, trend line, that is simply mentioned as expected value. Okay. expected value of y, we are expecting what is the value of y through the two parameter here, that is beta 1 and beta naught, with the help of change in x. Okay. Now, EI is the error term we already discussed. Now, these are called in this model. Now, since we have already started discussing about sample, we are saying these are called observed value. Okay. So, the observed values, and now try to understand one point here. Suppose I picked up this particular point. Okay. What does this mean? That this is indicating the value of y at this point, and this also indicated a value of x. All right. Now, in that particular line from this particular point till this, we reach at a predicted value. Our predicted value stands at the red line is our predicted line. Okay. So, the predicted value of y for xi is indicated at this line, at this particular point. Okay. So, that is all about our predicted value. So, then above to that, then what is this all about? That is basically the change from the predicted to other variable. The actual value is here. Okay. The actual value is here. So, the gap between these two is nothing but called error term. Okay. That is also called random error for the given value x. Similarly, there are many points, maybe this point, maybe this point, maybe this point, there are many possibilities. So, random error term could be estimated. Okay. Now, it is also interesting to note that our the particular point which we wanted to estimate, that from the how deviation is there, that is purely identified by the random epsilon term, but now our estimation follows with hat, beta naught hat with beta 1 hat xi plus epsilon xi. So, through that we can able to estimate. In this case, what is written here, look at carefully, the simple regression line provides an estimate of the population regression line. Okay. So, we are actually basically simply trying to estimate this is simply an estimate of the population regression line. We cannot simply say that this is the final estimation, we need to validate it by different reasons. Similarly, there are unsampled observation also. Okay. Unsampled observation as well, that has to be emphasized. Okay. So, some interpretations are here mentioned. So, random errors or the residual rules are the vertical distance, which I already explained from the beginning, the vertical distances from the individual points. So, from the trend line, from the individual points, like from the standard line, if you are considering this, the vertical differences are actually the residuals we go into estimate, and if it is the residuals are minimum, then we can find out a base fit regression lines. Okay. So, the base fit means difference between actual value and the predicted values are a minimum, but positive difference differences offset negative ones. In reality, we cannot estimate the two parameters because they are unknown. Okay. In practice, we can estimate of the parameters and substitute the estimates into equations. Okay. We can also convert it to equation with the parameters. So, the equation is how we estimate these parameters are very important. So, this is all the background information about the linear regression. In our next class, we are going to start with ordinary least square method, and also we will be emphasize the base fit line with r square, adjusted r square, and so forth. Many things are going to be explained. Okay. So, let me close here. Thank you.